Okay, well, we are going to continue to work with linear equations, and your learning target today is that you will be able to graph a line from an equation that has been written in slope-intercept form. If you recall, I've told you there are three ways that we're going to look at linear equations, three different ways that they can be written, and this is my favorite way. It's called slope-intercept form. In a little bit, we will also be talking about standard form, and then we will also be talking about point-slope form. But for now, it's slope-intercept form, which is this format. Y equals mx plus b, where m is your slope, and b is the letter they use to represent the y-intercept. Oops, that's kind of messy. Oh well. The y-intercept, don't forget, is where the line crosses through the y-axis. And then the slope is your driving directions, right? So, let's look at one. In blue, it says, graph the equation y equals negative 3x plus 3 and identify the x-intercept. I'm not super worried about the x-intercept yet at this point, but if we see it, I may touch on it here just a little bit, but I'm not super worried about x-intercept at this point. Oops, I guess we need to see that equation, don't we? There it is. So if I'm looking at my equation, y equals negative 3x plus 3, it is in good form. It's in slope-intercept form. I can easily find the slope. There's your slope, which is negative 3. I like it written as a ratio, so I'm going to say negative 3 over 1. And then b, the y-intercept, if I could write without, is right there. The y-intercept is a positive 3. At this point, you have everything that you need to graph this line. You don't need a table of values. You don't need a whole lot of ordered pairs. All you need is where does the line cross through the y-axis. That's your y-intercept. That's b. That's positive 3. And that's the first point that you plot. Once you have that starting point of the y-intercept, then you use your slope as your driving directions. So in this case, the y-intercept is positive 3. So that means on the y-axis, we're going to go up 3 and put a point. That's the y-intercept of my line. Now from there, I'm going to go back and look at the slope of my line and use it as my driving directions. The slope of the line is negative 3 over 1. So that means you go down 3, right 1, down 3, right 1. So on my graph, down 3, right 1 is there, and down 3, right 1 is here, and down 3, right 1 is here, and I could keep going. So if I connect my dots, disco, I just graphed a linear equation using the y-intercept and the slope. Now, earlier at the top of the slide, it did mention the x-intercept. Now, I'm not going to get too worked up about x-intercept yet, but this is the x-axis. Do you see where this line crosses the x-axis? Right there? That is technically the x-intercept. So, for future reference, the x-intercept of this line is the value of x where the line crosses the x-axis, which in this case would be 1. So if I really wanted to understand as much as I could about this line, not only is the y-intercept positive 3, but the x-intercept is positive 1. All right? But that's just kind of like a little glimpse into your future as to where we're going to be going with some of this. Let's do another one. This says the real-life application. Here we go. The cost y in dollars of taking a taxi X number of miles is represented by the equation y equals 2.5x plus 2. Let me talk briefly about really what they're saying here. They're saying that y, which is how much money you're going to spend total when you get in that taxi, is equal to 2.5 dollars times x, where x is how many miles you drive, plus 2. So this plus 2 out here on the right-hand side, that's like a flat fee. So as soon as you get in that taxi cab, it's going to cost you $2. And then for every mile you drive, or every mile that they drive you, it's another $2.50 per mile. So if you get in the taxi cab and you go 2 miles, well, it's $2 to get in the cab plus $2.50 times 2 for your 2 miles. All right, so that's kind of how this works. And you know what? Taxi cabs really do work that way. These may not be the exact values, but this is how it works. There's a fee per mile, and then there's just a base rate for even getting in the taxi and closing the door. Okay? So there's our equation. I think we have enough information that we can graph this line. Do you see the y-intercept? B, the y-intercept, is positive 2. M, which is the slope, is 2.5 over 1. All right, so we're going to graph this thing. The y-intercept is positive 2. Get some more room here. Right there. And the slope is up 2.5, right 1. Up 2.5, right 1. So up 2.5, right 1. Up 2.5, right 1. There you go. You just graphed the equation that represents taking a ride in a pretty expensive taxi cab. So this would be the cost of 0 miles, 1 mile, 2 miles, so on and so forth. And this would be $1, $2, $3, $4, $5, $6, $7. These are miles. And it's a little interesting if you sit and look at this. 1 mile costs $4.50. 2 miles costs $7 to ride in that taxi cab. Let's see, what else do we have? A couple more slides. Try this one on your own. Let's see what you can come up with. Well, it's already in good form. Y equals mx plus b. What's the m? What's the slope? I hope you guessed that. What's the y-intercept? So now plot B on the y-axis. Now use your slope to get another point and draw the line. So let's use our driving directions. The slope is negative 2 over 1. So you should know that means down 2, right 1. Down 2, right 1, down 2, right 1. And you can keep going so you get a couple points there to get a nice straight line. There it is, negative sloping line. Do you see an x-intercept? The x-intercept is right about in there. So right about, what would that be, like 2.5, something like that? Not too worried about x-intercept yet, but it's something to think about. There are a couple equations that I wanted to review quickly because it's important to remember that they aren't always written in the best form, right? Sometimes they rearrange the equation and they make you do a little bit more work. So I wanted to review this, even though I know we've already talked about it in class. I think it's worth reviewing a few more times. Remember, we are looking for this format. The y is on the left, then there's the equal sign, then there's your x term, and then sitting off on the right-hand side is your y-intercept, which is your constant, your b. So if I'm looking at this first equation, 4x plus y equals negative 1, and I'm trying to figure out who's not in the right spot, I'm going to say it's that 4x, this guy. He really needs to be right about there. So we need to bounce him over to the other side. Now, let me erase that. You should remember how you move things from one side of an equation to the other. We do the opposite. Right now, that is a positive 4x, and the opposite of a positive 4x is a negative 4x, or minus 4x. And you have to do that from both sides. So that goes away. On the left now, all I have is my positive y, which is good, that's what I want. Equal sign, and everything I need now is on the right. I've got my negative 4x term, and I've got my minus 1. So put that negative 4x term first. then your minus 1. Now it is in good form. You should be able to tell me what the slope is and what the y-intercept is. Slope is -4 or -4/1, and the y-intercept is -1. Look at that next guy over there on the right. Whoa, boy. Let's have a look-see at him. There's all kinds of stuff going on here. Who's not in the right spot? Well, I don't like this guy over here. He doesn't belong. And I also don't like that too. So the first thing you're going to do is move that 8x over. Bounce that 8x over to the other side. Then we'll worry about that 2 that's on that y term. We'll worry about him last. So how do I move that 8x? I subtract 8x. Both sides. Disco, that goes away. I've got my 2y there. There's my -8x. There's a positive 12. Now, cannot have a 2y. That's technically not in good form, right? I need the y to be alone. The only number the y is allowed to have is that invisible 1. So, how do I break that 2 off of the y? Do you remember? You divide by 2. So, everybody all the way across gets divided by 2. He gets divided by 2 so that it cancels. This guy gets divided by 2, and that guy gets divided by 2. You have to go all the way across when you're dividing or multiplying. So, y is happy. What is a -8 divided by 2? -4. X. And a positive 12 divided by 2 is positive 6. Slope of this line, -4/1, and the y-intercept is a positive 6. So that's just a little bit of a review of some linear equations that have not been written perfectly in slope-intercept form. Sometimes it requires you to do a little rearranging of the terms. But as long as you remember how to move things around from one side to the other, and then I just reviewed with you how to break a number like 2 off of a y, using division. If you can keep all that straight in your head or have it handy in your notes, you should do just fine. In class, we're going to be working on an assignment that covers all of this material. You'll get some practice graphing. All right, I'll see you then.